The sine law painting function is a third method which can be used to convert the value of a virtual painting pot into an amplitude value for the left channel and right channel of a stereo signal. The sine law painting function is different from the linear painting function, which maintains equal combined amplitude, and the square law painting function, which maintains equal combined power. The use then of the sine law painting function really just comes down to personal preference by the audio engineer. So let's take a closer look at using the sine law painting function. Here I'm going to demonstrate how to use the sine law painting functions. This will continue what we've looked at before with the linear and square law functions. In a previous video, I also did a comparison between various painting functions. We're going to add to that here by also incorporating the sine law functions. So at the beginning of this script, we're importing in a mono audio file that we're going to turn into a stereo file and use this painting value to decide what is the amplitude for the left and the right channels of our stereo signal. So we interpret this value, the pan value, that's on a scale from -100 up to +100. Transform it onto a scale of x that's going to go from 0 to 1. That will be the amplitude of the signal for each channel. So I have the functions already written out here for linear painting and also square painting. I'm going to comment these out temporarily so that now we can focus on the sine law painting. I'm going to move up this section in our code prior to the comparison so we can do that last. Also, I will temporarily comment out these lines of code so that we can just focus on setting up the sine law functions. So just as before, we're going to have a right amplitude and also a left amplitude. This is going to depend on our variable x. When it comes to the right amplitude, we're going to use the sine function in this case. It's going to be the sine of x times pi divided by 2. And our function for the left is going to be the sine, in this case, of 1 minus x, that quantity, multiplied by pi divided by 2. Now that's going to give us the amplitude values that we need for each channel, the left and the right. Then we can copy and paste this code that we've used before to create our stereo signal. And then also, if we like, we can listen back and see that things should be working correctly. To begin with, what I'll do is go up here and put in a pan value of -100. That should give us a value panned all the way over to the left. Now let's look at something panned to the center. So a value of 0. And something panned most of the way to the right. How about a value of 75? So now we have accomplished the sine law painting. Let's look at comparing it now with the other painting functions. That'll be linear and square law. So we're going to make use of this code that we used before. I'm going to uncomment it. In this case, we create a new variable x that can span the entire range from 0 up to 1. That way we can look at what's the amplitude and then what is the combined amplitude and also combined power. So our first plot that we put in here is going to be just the amplitude for each channel, starting with the linear functions, square root functions. Now let's add in our sine law functions. So here it's going to be x that we're plotting against the sine of x times pi divided by 2. And then we'll have x plotted against the other one. So now we can add to our legend, say that we have sine for the right and also sine for the left. So we'll now be able to look at and compare what is the level of the amplitude for these different functions. I'll comment out this code just temporarily, so we can just focus on this first plot. So here we can see that we have several painting functions plotted. Again, going from the beginning, linear is going to be the straight line for the blue and the red. It's the amplitude for each channel. So in this case, when we have a value of 0, that means our left one is going to be a value of 1, and our right one is going to be a value of 0, and so on. Then we also have these functions here that are in yellow and purple. Those are going to be the square root painting functions. So they are a little bit higher up, relatively speaking, on the plot compared to the linear ones, and they pass through this important point here, which is going to be just above 0.7. That's going to be where we're having the equal power then occurring when the signal is panned to the center. Then we also have the lighter blue and the green. Those are the sine law functions. And in fact, those appear as though they are, a little bit higher up. The amplitude is a little bit higher in most cases for the compared to the square root. But then as we drop below center, then that's where it's going to fall off quicker than the other one. So that's just a way to compare side by side what are the various amplitudes for the different functions. Now let's go on and plot the other things. So we'll look at the equal combined amplitude and also equal combined power. So here I'll uncomment the code. Go in here. This is where we're going to plot x against the sum of these two things. So I'll copy the whole thing just to speed it up. And what it is it's going to be addition here. So we're adding together what is the amplitude of the right channel plus the amplitude of the left channel. That will give us the combined amplitude here for sine. All right, then the last thing we can do, I'm going to copy this over. We'll look at the power. So down here, it'll be x plotted against, in this case, we only need one x. There we go. All right, so we need to square each part of this. We're going to square sine of x times pi divided by 2. Again, we'll use the pointwise exponent. And then we're going to also square this other part of it. Okay. Now we can look at combined amplitude and combined power. Sine power. We'll end up with 3 figures in this case. And let's compare them. I'll pull them out apart like this. So when it comes to our equal amplitude, we see that the linear painting function has a value of 1, no matter what our painting value is. And then we have different sorts of results when it comes to the square root and also the sine law. They do reach the same amplitude here in the center. When we pan it, have a value of 0.5 on that scale. They both end up having the same amplitude here, but on the left and the right, they're slightly different. However, when it comes to the power over here in figure 3, we are going to sacrifice, in the case of linear painting, we sacrifice equal power for equal amplitude. But then for our other functions, square root and sine law painting, they both maintain this equal power of 1, no matter what the painting value is. So this is a case where it's just a matter of personal preference. You're going to have equal power no matter what the painting value is, whether you choose square root or sine law. But in the case of the amplitude, it's whether you want the amplitude to be higher when you pan it off to the side or lower, for why you would choose the square root or sine law. So those are several different things to know about these different painting functions. We've now covered linear painting functions, square root painting functions, and also the sine law painting functions.